Milling of flat surface. This module will explain how to mill or face a flat surface with a vertical milling machine. Milling a flat surface on a vertical milling machine can be done with either an end mill or a shell mill, a facing mill, or a fly cutter. Actually, the different types of milling cutters are all kissing cousins, the big difference being the fly cutter. Select whichever cutter you prefer or is available to you. The important thing is that it will accomplish the job. The first step in making any setup on the mill is to sweep the table with a dial indicator and true the head if necessary. Put the vise on the table and secure it. It should be parallel to the T-slots. It is not necessary to align the vise for this operation. Mount the workpiece in the vise. If it is small, parallels must be used to raise the top surface above the level of the vise jaws. Next, select the proper cullet for the cutter being used. The cullet should be the same size as the cutter shank. Install the cullet in the spindle. Rotate the cullet until it seats properly in the spindle. Draw it partway up with a drawbar. This will hold it in place while inserting the cutter. Insert the cutter into the cullet, using caution to prevent cutting yourself on the sharp edges. Tighten the drawbar using the correct size wrench. There is no need to over-tighten the drawbar since the cullet has a self-holding taper. Remember to remove the wrench from the drawbar after the cutter is secured. A good suggestion at this point is to make sure that the quill is fully retracted, then lock it in position. This will prevent the cutter from being pulled down into the workpiece. An added safety suggestion is to run the micrometer stop up against the quill stop. The quill is now locked two different ways to prevent movement. Select the spindle speed recommended for the kind of metal you are going to cut. There are four main points to consider when selecting the correct spindle speed. They are the type of material being cut, the kind of cutter material to be used, the depth of cut being made, and how rigid are both the cutter and workpiece. On machines equipped with variable speed controls, the motor must be on before changing the spindle speed. If you are working with a belt drive machine, the motor must be off before changing spindle speed. If the motor is not already on, turn it on now. Make sure the cutter is rotating in the right direction. Raise the knee of the machine until the cutter just touches the workpiece. Look closely at the calibrated dial on the knee elevating control. It is calibrated in thousandths, each increment equal to 1/1000th of an inch. One complete revolution of the handle will raise or lower the table 100/1000ths of an inch. Loosen the locking device on the micrometer dial. Set the micrometer dial so that 0 on the dial is lined up with the index mark on the knee. Tighten the micrometer lock. Move the table so the workpiece clears the cutter. Then raise the knee to the height you want. This will be equal to the depth of cut. Never feed the cutter into the workpiece using the quill feed. Disengage the knee elevating handle from the cogs. This will prevent accidentally raising or lowering the table while cutting. Slowly feed the workpiece into the cutter using the table traverse control. Cut into the workpiece approximately 1 inch. Then back the cutter out and turn off the machine. Measure the width of the workpiece. Make sure there are no chips in the cut, as they can cause the micrometer reading to be inaccurate. If everything checks OK, lock the knee in position with a knee lock. At this point, you're ready to move the table into position to start the cut. The workpiece must be fed into the cutter correctly to prevent climb cutting. Conventional milling, or upcutting, means that the work is fed into the cutter against the rotation of the cutter. Feeding the work into the cutter in the same direction as the rotation of the cutter is referred to as climb cutting. Another good suggestion is to lock the saddle in position. This will prevent possible vibration or shifting of the table. Restart the mill and make the cut through the workpiece. Listen and watch carefully for any signs of trouble, such as chatter. Is the cutter making a full cut on the workpiece? It is best to make each cut slightly less than the diameter of the cutter. When you reach the end of the cut, loosen the saddle lock and move the cutter to the opposite front side of the workpiece. Again, tighten the saddle lock and slowly feed the cutter across the workpiece. Continue this method of cutting, always alternating back to front toward the center of the workpiece until the face of the work has been cut to the proper dimension. Stop the mill, then deburr the edges of the workpiece. When removing the cutter and collet, you must leave at least 4 or 5 threads on the drawbar engaged in the end of the collet. This will prevent damaging the threads on the end of the drawbar or on the inside of the collet when tapping the drawbar to release the holding taper on the collet. Remove the workpiece from the vise and clean up the machine.